episode 68 of the Real World Wellness Podcast. Hi everyone, I'm Christine Lehman, a nutritional therapy practitioner and the reverse diabetes coach, which is also the name of my website. I help clients reverse chronic conditions naturally through diet, exercise, and stress management. I see clients virtually, so you can talk with me even from the comfort of your own home. I am delighted to have my monthly co-host Amy Berger back on the show to talk about a condition called oxidative stress. But before we get into that, I wanted to remind you that Amy is both a certified nutrition specialist and a certified nutritional therapist. And she specializes in insulin resistance and Alzheimer's disease, which is sometimes referred to as type 3 diabetes. Amy also has been on the show to talk about her book, The Alzheimer's Antidote, which is available on her website. And Amy, you want to give out your website again?
Sure, that's tuitnutrition.com, T-U-I-T nutrition. But that's the e-book is available. The print book is coming out in March, and I think people should wait because the print version has been completely rewritten and updated, and I think that's just a much better version. But they can at least find out about it at tuitnutrition.com.
Okay, well that's very exciting. Congratulations. So since it's the holiday season here, I also want to mention that I wrote a blog post on healthy swaps for common holiday drinks and dishes, and you can check that out on my blog post page on my website, again, reversediabetescoach.com. So let's get into the topic of the day, oxidative stress. And listeners, you might have guessed correctly that it has something to do with oxygen. And just in case you need a refresher, which I think most people know this, we need oxygen to breathe and live. Without it, our organs couldn't function. And this is maybe a little bit new for some people. Oxygen also combines with digested food to burn fuel and give us energy. This is a metabolic process that is controlled, but if uncontrolled, can produce dangerous byproducts such as free radicals. So you might be wondering, what are free radicals? You may have heard about them, but to give you a little bit more information, they are created during the metabolic process of normal oxygen cells, or a process called oxidation. Free radicals are missing a simple electron, and they're searching around for another molecule that they can attach and combine with to become whole. So when they're looking for that other molecule to become whole, they fire charges that can damage other cells and structures around them. So oxidation in and of itself is a normal process. It's something we do, frankly, without thinking, and it's also a normal process involved in aging. One way to think about it is an iron pipe that's left outdoors. I think we've all seen or experienced this in our lifetimes. You leave something with metal outside, it's exposed to the elements, rain, sun, and air, which of course has oxygen, and come back, 2 weeks later, and it's rusted. And that rust is caused by oxidation. So some people draw an analogy with our bodies going through this rusting process as we age, which frankly doesn't sound too appealing, but you get the idea. So when this natural oxidation process is disturbed, though, and those free radicals are kind of scavenging around for another molecule in our bodies, the results can be toxic. And you might think of it as a balancing act. If there's a tipping point, it's really when we are producing too many of these free radicals. And also there are other pressures. We are aware, Amy, of toxins in our environment. It can be caused by pollution. It can be caused by radiation. Even in our water system, I think we've all heard about Flint, Michigan. And then in our food. And, the FDA is charged with regulating, harmful chemicals in our food. And I think overall they probably do a good job, but still some toxins certainly make their ways in there, and pesticides and things like that have a toxic, can expose us to toxins as well as tobacco smoke. For people who smoke, you're basically breathing in toxins. So all those things are things you need to be aware of and mindful of. because the more free radicals that your body has, the more damage it's likely to do. So the research has discovered that oxidative stress is linked or associated with several diseases. And these diseases include, they're pretty serious ones, like heart disease, cancer, arthritis, lung disease, which isn't surprising, I think, especially if you're a tobacco smoker. Fibromyalgia. I talked to a clinician who specializes in treating chronic fatigue syndrome and fibromyalgia, and we talked a little bit about oxidative stress, which is common in these conditions as well, and why you want to engage in low impact exercise, low stress exercise. Diabetes, which we're going to really delve into more today, especially type 2. And then there are neurodegenerative diseases like Parkinson's and Alzheimer's. And I know, Amy, you're going to talk a little bit about the role of an antioxidant, ALA, in relation to Alzheimer's a little bit later. And then it's also associated with autoimmune diseases and eye diseases like macular degeneration. So I wanted to really hone in on the relationship between oxidative stress and type 2 diabetes. And just as a refresher, diabetes, the official name is diabetes mellitus. It's characterized by metabolic diseases that are in a chronic state of hyperglycemia. And that results from a defect in insulin secretion, insulin action, or both. And hyper is pretty much the way it sounds. You have too much of sugar circulating in your blood, and then it raises your blood sugar level certainly to above normal, and this is kind of a chronic constant state for you. So the researchers have established pretty well that type 2 diabetes is associated with increased free radical activity. And in one study, I thought it was interesting, they use what's called a biomarker, which is a way of measuring a certain state. So they use this chemical biomarker called malondialdehyde.
Malondialdehyde.
Thank you, malondialdehyde. To measure lipid peroxidation. Now, lipids, and I know you're going to go into this, it's a term for a group of fats. And so they were measuring lipid peroxidation of these membrane fats or lipids, which is directly proportional to the oxidative stress on the membrane. So what was interesting in one of the main findings is that, in fact, this particular chemical called malondialdehyde, you want to say it, Amy? I'm having trouble with this.
Malondialdehyde.
Thank you. Increased, and when they measured it, again, it's directly proportional to levels of oxidative stress. So they found that this particular increase was definitely associated with oxidative stress in type 2 diabetes, and it just adds another evidence to support that oxidative stress does exist in people with type 2 diabetes. So just to understand the mechanism a little bit more, this heightened state, if you will, of blood sugar in hyperglycemia generates these free radicals and creates the oxidative stress, which impairs our normal internal antioxidant defense system. So our bodies do produce antioxidants naturally. And the common ones that I think most people have heard about are vitamins A, C, and E, and perhaps you've heard about this tripeptide, which means three, glutathione, glutathione, and the enzyme superoxide dismutase, catalase, glutathione peroxidase, and glutathione reductase. So those are different forms of glutathione. And often those are found in supplements. I know Biotics uses these. And then there's also, and Amy, you're going to talk more about these Other antioxidants include A or alpha-lipoic acid, mixed carotenoids, coenzymes. I think a lot of people are familiar with the one CoQ10. Several bioflavonoids, and antioxidant minerals. We don't want to forget about minerals, which are often deficient. The research has shown in many people: copper, zinc, manganese, and selenium, as well as the coenzymes, folic acid, the B complex. And I thought what was interesting here is these different antioxidants work in synergy with each other and against different types of free radicals. So they have their own separate roles, but then in combination, they also have kind of a synergistic role. And they also have their own mechanisms for reducing oxidative stress. And for example, vitamin E suppresses the propagation of lipid peroxidation, and vitamin C with vitamin E inhibits hyperperoxidide formation. So that just illustrates that they have their unique roles, but in combination also have roles to play. So the authors, in conclusion, called for the use of antioxidants to combat the oxidants, thereby decreasing total antioxidant. That would result in the decreased total antioxidant status. So essentially, you want to fortify your antioxidant defense system. Now, a second article really gets to, I think, more at the heart of type 2 diabetes. Again, insulin is involved. There's a condition called insulin resistance, which has to do with impaired insulin levels and function. And so this particular study, and it's a meta-analysis of 14, that's really what meta-analysis means. They look at several studies and review them in the literature and then come up with some conclusions. So this one, again, reinforced that hyperglycemia generates free radicals during this protein glycation, and that they measured with the hemoglobin A1C test. But they also found that the glycation end products bound receptors that impair insulin signaling pathways and also create toxicity in the pancreatic beta cells. And those beta cells are responsible for releasing and secreting insulin. So they wanted to find out, the authors did, whether increasing your antioxidants could improve or mitigate these effects, which would certainly help people with type 2 diabetes. So when they reviewed several studies or meta-analysis, they looked at whether supplementing diet with antioxidants, specifically C and E, would improve plasma glucose and insulin concentrations, or which would help interfere with the disease process, and or on this hemoglobin A1C as a measure of antioxidant effects on protein modification, which is a little more science. But essentially, keep in mind that they're measuring your H1C as well as the plasma glucose and insulin to find out whether this in fact works. So the results revealed that dietary antioxidant supplementation did not affect plasma glucose or insulin levels, unfortunately, suggesting they could not interfere with the process of insulin resistance. But this is the good news here. Their hemoglobin A1C levels were significantly reduced by antioxidant supplementation, again, looking specifically at vitamin C or E, suggesting that they could have some benefit in protecting against the complications of type 2 diabetes. So I thought that was interesting because, there are a lot of supplements out there, and I think it's important to understand what their roles are in this and, what they can and cannot do. So do you want to talk a little bit more about antioxidants, Amy?
Sure. So I think, we talk about oxidative stress and, I guess, what do antioxidants do, right? They quench free radicals, and that means, they sort of protect against this oxidative stress that we've been talking about, or they kind of limit it. So free radicals are molecules that are missing an electron, or they have an unpaired electron, and the antioxidant basically donates an electron to this molecule because it's that unpaired electron that sets off the chain reaction of oxidation. And if these molecules receive an electron to pair, then they don't go damaging other stuff. And the free radicals, I've called them pinballs before. They're like these pinballs that bounce around the cell, knocking into structures and molecules and damaging them. And those structures could be DNA, they could be cell membranes, they could be lipoproteins. So, for example, like the low-density lipoprotein that transports cholesterol, if that has become oxidized, the LDL receptor no longer recognizes it. And what does that mean? Well, if the receptor doesn't recognize it, that LDL particle is going to stay in the bloodstream. And there's a lot of stuff coming out about, the role of LDL in cardiovascular disease. But the point is, if they start accumulating, why does somebody have very high LDL? It could be because the receptor is not recognizing it. It's not letting that particle, or that cholesterol get into the cell. So anyway, that's just one example, but there's all different kinds of structures that can be damaged by this, so we do want to limit it. But, oxidative stress is two important points I want to make. The first is that this is not always a bad thing. Oxidative stress is a natural, normal process that we need to happen in the body. It is, how do I explain? It's one of the defense mechanisms that the body uses for a couple of different things. One of them being the immune system. If, by oxidizing invading pathogens, that's one way the immune system sort of attacks these harmful molecules. It's also one way that we can, I don't know if it works to chelate heavy metals, but it may help to sort of tag them for removal. It tags other sort of toxins for removal. And so you don't want to have no oxidation. It's a normal thing. It happens through normal metabolic processes as well. Just the metabolism of food, different biochemical processes that happen. It's also one way that the body may fight against cancer is by attacking cancer cells with reactive oxygen species. And if I'm not mistaken, that's one of the things radiation treatments are designed to do, is basically blast these cancer cells with free radicals, and it destroys them. So, people have taken massive doses of antioxidants, and it's actually harmful. So there's, like with any other nutrient, there's a balance. We want some oxidation, but not a ton, but we don't want to stop it completely because it happens for a reason. Just pretty much everything that the body does happens for a reason, and it's only problematic when it gets out of control. So, the other point that I think is important for people to understand is that increased oxidative stress is more likely an effect of chronic illnesses rather than a cause. And it may be exacerbating certain conditions. It may be making them worse, but it's, at least in my opinion, unlikely to be the primary cause of some of these conditions. For example, with type 2 diabetes, of course there's increased oxidation. Why? Because of chronic hyperglycemia, chronic hyperinsulinemia, chronically high blood sugar and insulin. That's very damaging. But the oxidative stress is the result of that, not the cause. So you do want to control that while you're getting blood sugar under control, but the solution to sort of resolving that is not mega doses of antioxidants. It's to get the blood sugar and insulin down. And in the short term, supplementing with antioxidants can probably be helpful, but that's not going to do much to bring the blood sugar down. The blood sugar isn't high because of a lack of antioxidants. So that's the thing. People sort of hear, oh, free radicals, oxidation, it's bad, but what is it doing and why, and what do we do about it? So let's see.
Right, and if I could just interject, going back to that study, I mean, it's not going to necessarily prevent type 2 diabetes either, but it can help. The vitamin C and E could help reduce your blood sugar levels. Is this, if you're taking them as in food, or supplementing food, or in I guess more of a pill form, they may help prevent to further complications. And I think you'll there's some research behind alpha-lipoic acid, for example, but I also want to say these studies, they're not super conclusive at this point, but there is some, this one study I cited said it could be beneficial.
Right. Well, I think an oxidative stress is kind of like, even if it is a symptom of some of these conditions rather than a cause, we still want to address the symptom. I mean, if you have a very high fever because of an infection, well, the answer is to cure the infection, but you still need to manage the fever if it's going too high. The fever is the protective mechanism, but if that gets out of control, the fever itself becomes a problem. And I feel like we could say the same thing about oxidative stress. I mean, it's the body's way of handling certain things that are going wrong in the body, but that doesn't mean that it's completely harmless itself, So that may be where antioxidant supplements and in food supply come in. And I think also it's worth noting that a lot of these conditions, whether it's diabetes or a neurological condition, are like we said, associated with oxidative stress, and they're also associated with lower levels of these antioxidants. And so the first thing is, why are there lower levels? And I think it's probably, it could be because there's not enough in the diet to begin with, that people just aren't taking in enough of these compounds. Could be that their own bodies are not producing enough. But I think both of those go hand in hand with the increased demand for these molecules. Like if you are chronically sick, if you do have chronically high blood sugar and insulin, or you have some other, mitochondrial defect, such as in Parkinson's disease or ALS, that is creating more oxidative damage, then you need more antioxidants. And so I feel like when they measure these levels, it's probably just that supply is not meeting the demand. And
right,
it's kind of like these conditions deplete antioxidants. It's not that low antioxidants are causing them, but these conditions increase the requirement and the need for them.
Yeah, no, that makes sense.
Yeah, it's almost like your body is spinning through them so fast, and if your body can't keep up with it, then you need to supplement, at least in the short term, until whatever this condition is resolved. Or if it can't be resolved, then maybe you need to be on a maintenance dose for a long time. But and then I wonder too, and they don't. I feel like a lot of the studies don't address this issue of measuring some of these compounds in the blood, but where they perform most of their actions is inside the tissues, inside cells, inside organs. So I'm not saying that measuring in the blood is useless. I mean, obviously it's not, but I feel like they don't always measure in the locations where these would be having their greatest activity. But that, you can still measure it in the blood. I mean, if the blood is low, then there's probably already a problem, but we can't assume what's going on in the tissues. So we get, the body generates antioxidants on its own. There's a lot of different internal endogenous antioxidants, but we also get them from the outside, from our food. And even the ones that we produce ourselves, they don't come out of nowhere. They don't exist in a vacuum. They're made from vitamins and minerals, from, different amino acids, lipids. Like we need the raw material to produce these things, even for the ones our bodies can produce. So there are supplements, and supplements can be very helpful in certain cases, but we would prefer to get them from food, and there's a couple of reasons. I mean, the first is that most of the supplements out there, there are some brands that are very, very good, and they're more expensive because of this, but some, for example, vitamin C is a well-known antioxidant, but vitamin C is more than just ascorbic acid, and most vitamin C supplements are really just ascorbic acid. Same thing with vitamin E. Vitamin E is a complex, and many vitamin E supplements are only alpha-tocopherol or gamma-tocopherol, fractions of what the full spectrum of the nutrient is in nature. And that doesn't mean these supplements don't work. It just means they might not work as well. Or maybe you would need a higher dose of a synthetic form than you would get from food, because there's these synergistic components that we can't replicate in a lab. And not only can't we replicate them, we don't even know about them. I mean, these nutrients are very complex, and I feel like we don't really even have an appreciation for the interactions and how, just what a spectrum they are. It's very rarely one single compound. So then besides that, there are, like for example, again with vitamin C, at least in citrus fruits, comes with bioflavonoids like lutein, like I think it's hesperidin or hesperidin, I'm not sure how to say it, but those are sort of compounds that work alongside vitamin C, and maybe we even need them to make the vitamin C be more effective. Mm-hmm. And those are often not included in vitamin C supplements. And one final issue with taking them in supplement form is that these molecules have a certain chemical structure, and a lot of different molecules, be they carbohydrates or amino acids, have different forms of this chemical structure, and they don't all work the same. So, like for example, if you've ever taken amino acid supplements, they usually start with L-tyrosine, L-tryptophan. Some of the sugars like ribose or mannose are always D-ribose, D-mannose. That has to do with the type, with the orientation of the chemical structure. And so in nature, they usually exist either in one form or another, or both. And this sort of determines the efficacy. Maybe in some cases it's only the D form that's effective, or only the L form. And in supplements, it depends on what form the manufacturer chooses to make it. Sometimes they make it mixture, sometimes it's only one. So that's a factor. And I'm not trying to complicate matters. I mean, I do think supplements can be effective, but this is just why it's best to get as much of this from food as we can, and then maybe supplement on top of that.
Yeah, that makes sense.
Yeah. I mean, I've always, food is the best, and foods that contain antioxidants are delicious.
Mm-hmm.
Who wouldn't want to eat these foods anyway? But probably supplementing can just be kind of give somebody a leg up, because it is hard to get these things from the food supply. I mean, and especially if you are very sick, if you're chronically ill, you might not be able to even get enough from food, just because there's only so much a person can eat. Mm-hmm. And in those cases, there may be cases where what I would call a therapeutic dose, or like a medicinal dose of supplemental antioxidants, can help. Mm-hmm. Like if anyone knows about Linus Pauling's work, I mean, he would give people these massive doses of vitamin C, and it was helping people left and right. And so that's way more vitamin C than they ever could have gotten from food. Mm-hmm. So some of the foods, let's see about, we talked about vitamin C. Everyone kind of knows that vitamin C is found in citrus fruits, also kiwi and strawberries, but for those of us who watch our fruit intake for blood sugar control purposes, there are plenty of lower carb foods that are that are good sources of vitamin C. So any kind of bell pepper, broccoli, mustard greens, kale, and onions. And I think red onions might have more, but I think even yellow and white onions are still a good source. Vitamin C is not heat stable. I think it's destroyed by cooking. So
it does depend a little bit on the particular vegetable.
Okay.
Because I had Joe Robinson, who wrote the book Eating on the Wild Side, and believe it or not, some things like, and we're not talking about tomatoes, but tomatoes have more lycopene when they're cooked.
Right.
And tomato sauce, for example, is more concentrated than just eating a raw tomato.
That's true. Yeah. But the vitamin C content is may not be as high, but it's not completely destroyed. It just is less. And if you're just don't cook the HDCK out of these things, and we'll be fine. Like if kind of steam it, saute it. If there's still a little bit of crunch to it, probably there's still some vitamin C. But no, you are correct about the lycopene. That's an interesting case that concentrates when it's cooked and when it's processed. And definitely, it sounded tomato paste has some of the highest concentration of lycopene, probably because it is so concentrated. But as long as we're talking about lycopene, let's go to the carotenoids. Carotenoids are, they probably get their name from carrot, beta-carotene, and that is a fat-soluble compound that is a form of antioxidant, and it's responsible for some of the pigment in brightly colored fruits and vegetables. So there's a lot of different kinds. Different carotenoids are present in different foods, but as a whole group, they're found in the yellow, orange, and red plants, and also the green ones. Usually the yellow and orange pigments are hidden by the chlorophyll in something like, Brussels sprouts or spinach or kale. But we're more familiar with carotenoids coming in things like sweet potatoes, winter squash, watermelon, tomatoes, red peppers, pumpkin. Lutein is a carotenoid that is actually the best source of egg yolks. Egg yolks don't contain as much lutein as certain yellow plants, but it's more bioavailable, so you wouldn't need as much. Other antioxidants, so green herbs are surprisingly high in antioxidants. Now, it's hard to kind of eat enough to get an appreciable amount. I mean, nobody's going to eat a cup of parsley, but things like parsley, oregano, basil, and rosemary are loaded with antioxidants.
Yeah, and a good pesto sauce would have more in there.
Yeah, that's true. And you could use a lot. Some people like to use fresh parsley or cilantro in a salad, like pretty significant amount of it, and that's good. It's funny, some fatty acid supplements, whether it's fish oil or some other compound that's in a carrier oil, sometimes you'll see on the label that it's packed with rosemary extract, and that's specifically because rosemary is there to protect against oxidation of the fats. So, yeah, that's used as an antioxidant even in supplements that contain oil. Speaking of oils, vitamin E is a good antioxidant, and it's found mostly in fatty foods, like nuts, seeds, and certain oils. Sunflower seeds and oil is a really good source of vitamin E. Avocados are a good source. There's some in terms of animal foods in shrimp and rainbow trout. And so I think I mentioned before, there's, alpha-tocopherol, gamma-tocopherol, there's also tocotrienol. Vitamin E is made up of 8 different sub-fractions. And the alpha-tocopherol portion of E seems to be the one that is the most bioactive. It's the one that sort of is responsible for the vitamin E activity. The other kinds have a little bit of alpha-tocopherol is the most potent, and gamma-tocopherol, however, is the most abundant in our current food supply because it's high in soybean oil. Now, of course, we do not recommend soybean oil because of many other problematic issues with it, but that happens to be a good source of at least the gamma-tocopherol.
Just to clarify, Amy, is the gamma you're saying is not as effective, though, in absorbing perhaps the vitamin E as the alpha version?
Yeah, I don't know if it's an absorption thing or like a bioactive thing. It's just not as potent as the alpha, which is, that's why it's best to just get it from a whole food anyway.
Yeah.
So just eat the sunflower seeds, and maybe even the oil too would have it. But this, all of this stuff kind of speaks to eating a varied diet, right?
Mm-hmm.
We get some antioxidants and vitamins from fatty foods, we get some from animal foods, we get some from plant foods, and a variety of colors. So I think, you and I don't always agree with modern dietitians and some of what the Dietetics Association puts out, but I think they're right when they say eat a rainbow.
Right. Yeah, I've heard that.
Eat a varied diet, get lots of colors, because all of these different things provide us with different nutrients. Besides the fact, like I said, they're delicious, and they make eating this way interesting.
Mm-hmm.
Instead of having like the same bowl of cereal every morning, you can have such a different wide variety of vegetables. I mentioned alpha-lipoic acid briefly, and I'll just call it ALA, so we'll make sure that people know that at least for now, that's alpha-lipoic acid. I'm not talking about alpha-linolenic acid, which is an omega-3 fat. So ALA is a very interesting and very powerful seeming antioxidant. It's antipathic, which means it works in lipids and water, so it's an antioxidant that can work in the cytosol, it can work in the blood, it can work on cell membranes, it kind of works on everything. And they call it a universal antioxidant or an antioxidant of antioxidants. And they call it that because it helps to regenerate other antioxidants, especially vitamins E and C and glutathione. So antioxidants work by becoming oxidized themselves. I think you mentioned that earlier. They sort of sacrifice themselves to protect another molecule. So when that molecule has then become oxidized itself, alpha-lipoic acid, it's called reduction. It reduces that molecule. It's the opposite of oxidation. It regenerates or recharges that molecule so it can work again. The pairing of alpha-lipoic acid and its own reduced form, which is called, we're getting too deep in the weeds, so let's take a step back. Alpha-lipoic, it's just a very powerful antioxidant. And it may be even more powerful than glutathione, which is sort of referred to as the body's master antioxidant. But if alpha-lipoic acid can help maintain a good supply of glutathione, then they kind of go hand in hand. So alpha-lipoic acid is synthesized in the body. It's one of those compounds that we do make ourselves. But, some people, their bodies might not be able to keep up with the demand, like I was mentioning earlier. And so it is found, there's small amounts in plant foods like spinach and broccoli, Brussels sprouts, but the major sources of ALA in the diet are animal foods, and especially in what we would call hard-working tissue, like organ meat, heart, kidney, liver. And people aren't eating that much heart, kidney, and liver these days. I mean, some of your listeners might be, because that's just, we don't really eat the normal American diet, but those would be good sources. And for people that think their own production is not really up to snuff. And this alpha-lipoic acid, besides being an antioxidant, it's important for the breakdown of branched chain amino acids. It's important for energy production. Just if people have ever heard of the Krebs cycle, basically the biochemical processes by which we turn food into energy at the cellular level requires alpha-lipoic acid. So because of its role as an antioxidant, they've used ALA in some studies they've used it in studies for a lot of things, but regarding type 2 diabetes, it has shown some pretty good efficacy for reversing diabetic neuropathy, which is the nerve damage that some people experience when they start to feel tingling or pins and needles in their extremities, their hands and feet. It's usually given in very high doses. We're talking over 1,000 milligrams a day. Sometimes it's even given intravenously, and at a lower dose usually, because it may be more effective going directly into the blood. But in in Germany, where I guess the stuff is not available over the counter, oral and IV alpha-lipoic acid are approved for the treatment of diabetic neuropathy. I mean, it's considered a medication there. That's how effective this is. Let's see. What else? So, it specifically for type 2 diabetes, alpha-lipoic acid protects against that neuropathy, and then it actually helps in glucoregulation itself. It facilitates proper function of the insulin receptor and also proper functioning of some of the glucose transporters. So, there's been so many studies on this, but there's, some of the studies show that doses of at least 600 milligrams a day of oral alpha-lipoic acid, once, twice daily will be 1,200 a day, but divided doses, it improves insulin sensitivity and glucose disposal. And sometimes it actually brings those diabetics to the same level of healthy non-diabetic control subjects. So it's really, it is really powerful, but I still think that's more symptom management. I don't think somebody could take alpha-lipoic acid and continue eating a very high carbohydrate diet and expect to prevent further complications of diabetes.
Right. It's taking a holistic approach here. As you pointed out, I assume these studies were done with, that's interesting. The German one was not done with just supplementation, but an IV. And some high doses here, but that food, again, we would recommend food sources and then perhaps supplementation through a more synthetic version.
Right. And it's, they have looked at ALA for Alzheimer's disease, and I wrote about this in my book really briefly because, in my opinion anyway, anything that helps control insulin and blood glucose may be beneficial for cognitive function. And so they've done some studies. It's pretty limited, but the studies of alpha-lipoic acid for Alzheimer's disease does show that in the short term it improves memory a little bit, and it slows further progression. It slows the rate of cognitive decline, but it doesn't stop it, right? It doesn't prevent further decline. It just slows it. So, for example, two people with Alzheimer's disease, one supplements with ALA, the other doesn't. The one supplementing might, and I emphasize might, have a slower decline than the other one. And I think it's the same thing as anything. I mean, it's not a miracle pill. None of these antioxidants, none of these compounds work in a vacuum. They're not magic potions. They have to be part of a multifaceted strategy for managing whatever condition somebody has. And I also think some of these studies that show that a certain compound doesn't have efficacy, whether it's lipoic acid or vitamin C or, beta-carotene, it's not always that the compound itself is ineffective. It's more that the compound by itself alone with no other intervention is not effective. You know what I mean? Like that's, I found that in so much of the Alzheimer's research. It's a byproduct of the way the research has to be conducted in order to determine the efficacy of a particular substance. They have to only give that substance, right? Because if they give it in combination with anything else,
right,
there's no way to conclude for certain whether it was that compound or something else or some other part of the intervention. So when you only give alpha-lipoic acid and nothing happens, well, okay, no big deal. What if we gave alpha-lipoic acid and put them on a ketogenic diet and made them exercise? Then maybe the combination would be a huge boost. And it's, like I said, I understand why the research has to be conducted that way, but I think it limits some of the findings that we might get with any of these compounds.
Yeah, that's a very good point. If they were, instead of isolating the compound to avoid what they call confounding variables, they were to take this multi-pronged approach that we actually take in practice, right? Which is diet, whether it's paleo or ketogenic, a whole foods diet, which
Right.
would include all these things just naturally, right? Healthy fats, healthy proteins, healthy carbs.
Exactly. And it's kind of like an example is, I think it was Ornish, it might have been Prediction, but I think it was Dr. Ornish who several years ago had his program where they basically reversed heart disease, and it was attributed to the vegan diet, except the vegan diet was not the only intervention in his protocol. There was a diet, they quit smoking, they exercised, they started meditating, they had social support. There was a lot of factors, except every time people cite that program as reversing heart disease, they only mention the vegan diet.
Mm-hmm.
Or they don't only mention it, but they attribute most of the effect to the diet.
Mm-hmm.
And maybe it was. I mean, I'm not saying it's not. I'm saying we can't know for certain because the vegan diet was not the only change those people made.
No, I think
it's hard to say about these antioxidants, but for alpha-lipoic acid, I will say just for the listeners out there, after researching alpha-lipoic acid myself several months ago, I tried it because I was impressed by the research, and I thought, wow, this is something I should take. I mean, that's how impressive I found it. And I had some interesting, what I would consider negative side effects. It's because it's possible that it can chelate heavy metals. It may be that it was sort of freeing up some of those things in my body to be released, and maybe I wasn't excreting them efficiently, and so they were building up and affecting me. I'm not really sure, but I'm normally pretty even-keeled and a pretty, emotionally balanced, strong person. And I took alpha-lipoic acid on 3 separate occasions, and it turned me into a weepy, emotional basket case. And it's so interesting because it's the only change I made, it's the only thing I did differently, and it happened every time. So,
what was your dose?
Sorry, what?
Well, how much were you taking? What was your dose?
Oh, I don't remember offhand.
I was just wondering if it was on the high end, or how would you, like...
I don't even remember. Let me see if I can find the bottle right now as we talk, but I'm pretty sure I threw it out because I was so...
It wasn't working for you.
So, alarmed by those symptoms. I don't think I have it anymore, but... I don't think it's necessarily that alpha-lipoic acid is bad. I think maybe it was doing something to me that my body at that time was not prepared for.
Right.
Because if it does chelate heavy metals, that's actually a good thing.
Right, you were detoxing.
Right. It would have been doing that for me, and maybe I just wasn't able to get rid of that stuff enough.
Mm-hmm. Well, I think you're raising a good point because, it's good for people just to realize that it may be unlikely, but it could be a reaction, and this is maybe what's happening. So, I don't know. Did you give up prematurely?
I don't know. I mean, I'm willing to try it again. Or maybe I just don't need it. Maybe that's my body's way of saying, hey, you don't need this. But I'm looking at the label now. It was 300 milligrams of alpha-lipoic acid, and I probably took 2, so it was probably
that's pretty low.
But
yeah,
the product, it wasn't too high. The product was a combination product. It also had 4 milligrams of biotin, which is a lot. That's pretty high for biotin, and also had 500 milligrams of taurine, because taurine kind of helps the liver to detox certain things. So, I guess I can't even say it was lipoic acid for sure, but I've taken biotin in the past and been fine. So that was interesting because I really wanted to take it. I felt that the research was so impressive, and I thought, I wonder if you feel that way, and listeners might think this is funny, in the course of your research, you almost become a hypochondriac. You find out about some new condition, or especially some new supplement, you think, oh, I should take that sounds really good, and it's hard to sort of control yourself when, I don't know, I just find sometimes I fall prey to that. If I find out about something new that I didn't realize that sounds really good, I want to try it, when, not everything is appropriate for everybody.
Right. No, I think that's a very good point. Even when you talk about medications, I used to report for Psychiatric News. They always drew this analogy of kind of a key and a lock and the fit. And that's why some medications don't work as well in some people as others. And but I do think ALA definitely has enough fair amount of research to show that it does have some benefits, and I think it's worth trying. I have ordered it for a few clients. I'm waiting in combination. I think that's a key point with a whole strategy, a very holistic strategy. So I'm waiting to see if that, can help, especially frankly with their blood sugar numbers. If that's one more tool that I can use to increase, their antioxidant strategy and hopefully decrease their, A1C levels. I think that would be great.
Yeah. Yeah, there are, I think any of these supplements, they're exactly that, right? They're supplemental to a good diet, different lifestyle interventions. So I feel like, because there are people who will still struggle to get better blood sugar or insulin or lose weight, even when they're doing what we would consider all the right things, right? Even when they're working hard, for some reason things just aren't going as well as we would want them to. And in those cases, definitely supplementation, I think, is just one extra little way to get things moving.
Right, and the other benefit of ALA is this whole issue of diabetic neuropathy, and I definitely have I have 2 clients who are experiencing issues with that. Neuropathy again is nerve damage, and one client has progressed further, and so I'm definitely interested also in seeing whether ALA helps with that.
Mm-hmm. Are they, just out of curiosity, are they doing B12? Because B12 is huge for neuropathy.
Mm-hmm. I think they're on a kind of a multivitamin that may include B12, but
and I know if they happen to be on metformin, you probably already know, but metformin depletes B12 over the long term.
Yeah, and actually neither one of them. One went completely natural, never got on metformin at all.
Oh, wow.
Yeah, and the other one, metformin didn't work, and they put her, unfortunately, on insulin. So it's been kind of a slow road to trying to titrate her off the insulin, just because there's some real fluctuations there that get too high. Yet it's not as, I'm waiting for a period where it's controlled better. To then, but we're using ALA, we're using like glucobalance, things that also, she's on some blood pressure medication as well that can interact with the berberine. So I just didn't go there yet with her. So this is a complex case. So you also have to look at, interactions between supplements and any medications that they're on.
Mm-hmm. Well, speaking of medication, we have a couple more minutes. If you want me to say something about statin drugs, because statin drugs, people probably know this already, they deplete something called coenzyme Q10. And CoQ10 is an antioxidant. Well, it does a lot of things, but one of the functions it has is as an antioxidant, and it's one of those that we do produce. We produce it in our bodies, and we can also get it from food sources. But the way we produce it in our bodies is through the same biochemical pathway by which cholesterol is produced. And it's the same pathway that's inhibited by statins. And one of the very, very well-known side effects of statin drugs is depletion of CoQ10. And CoQ10, it's part of the electron transport chain inside the mitochondria, and it actually produces energy. So there's a reason why fatigue and muscle weakness and muscle pain are signs or side effects of statins, because your body literally has impaired capacity to generate energy. So no wonder you're fatigued. I think it's also why some of these, statins are, I think, a major factor in cognitive impairment. And again, it's because those brain cells are starving for energy. It could be a factor in any neurological disease, especially some of the ones that involve trouble moving, like multiple sclerosis, like Parkinson's, like ALS. I'm not saying statins cause these. I'm definitely not saying that, but anything that impairs impairs the production of energy in the mitochondria is going to have a major impact on muscle function and movement and coordination. So that's, I just think, antioxidants are so important for mitochondrial health. And I think the one in the mitochondria requires manganese as a cofactor, and the ones in the rest of the cell use copper and zinc. So like we were saying at the beginning, we generate a lot of these antioxidants in our bodies, but we do need the vitamins and minerals that are the cofactors or the precursors to some of these. We can't just generate them out of nowhere. So, yeah, medications definitely can deplete some of these compounds, and they can, increase the body's need for them.
Yeah, absolutely.
So yeah, I think in ALS, I think I talked about this in the podcast we recorded a while back about ketogenic diets for neurological health, but if I recall correctly, ALS is, I don't know if it's caused by or just associated with, but one of the big issues with ALS is a problem with the enzyme superoxide dismutase, which is an antioxidant. It quenches the superoxide radical, which does major damage to the mitochondria, to cells, to lipids, the cell membranes. So I think that is a genetic thing. That's not something that we really bring upon ourselves. It's not like a dietary thing. It's not a lifestyle thing. It just befalls some people. But it's interesting that whatever is really part of what's going wrong in ALS is a major problem with production of one of the key antioxidants.
Yeah, that is really interesting. So I think we're going to wrap up. I want to thank you again, Amy, for being on the podcast today.
Yeah, always a pleasure.
And listeners, I want to make 2017 episodes more interactive, so I would love to hear from you, your thoughts, your questions, comments. Please send them to me at Christine@reversediabetescoach.com. I'm going to be recording a few episodes on how to make New Year's resolutions stick and turn them into long-term habits. So feel free to share your New Year's resolutions with me, again at Christine@reversediabetescoach.com. And I hope you have happy holidays.